Okay, in this application question, we've given a function and asked to find the value of the gradient function when x is equal to pi over 3. So the first thing we're going to need to do is differentiate this. Now you need to spot what you're dealing with when you differentiate it. We're dealing with a function multiplied by another function. So we're dealing with the product rule. So let's start by defining all of our various parts of the product rule. So let's let u equal cos x, v equal tan x. Differentiate u to get u dashed. To find out what happens when we differentiate cos, we get minus sine. When we differentiate tan, we get v dashed is equal to sec squared. So now when I find f dashed of x, using the product rule, I'm going to get this one multiplied by this, add this one multiplied by this. So I'm going to get cos x sec squared x, add minus sine x tan x. Okay, just combining those two together. So now all I need to do is find what the value of pi by 3 is of each of these functions. So now I've got cos pi by 3, sec squared pi by 3, minus sine pi by 3, tan pi by 3. Now pi by 3 is handy because it means I don't need to pull out my calculator. I can do it just by thinking about my triangle. Now pi by 3, 180 divided by 3 is 60. So this is going to be 30 or pi by 6. This is going to be 60 or pi by 3. And I know that sine of 30 is a half. So 2 squared take away 1 squared. This is root 3 by Pythagoras. So I know that cos of pi by 3, which is here, is just a half. Sec squared is 1 over cos squared, and a half squared, so if cos pi by 3, this is 1 over cos pi by 3 and then squared. So cos pi by 3 is a half, sec pi by 3 is 2, and sec squared is 4. Right, sine of pi by 3, so here we are, will be root 3 over 2, so minus root 3 over 2, and tan pi by 3, opposite over adjacent, will just be root 3, and I haven't even had to use my calculator, which is fabulous because it's still in my bag. Right, 4 times a half is 2, minus root 3 times root 3 is just 3, so 3 over 2, 2 take away 3 over 2, well that's just a half, folks. Job done.